Okay, so in this video, we want to determine if the table represents a linear model or not. So in order to be a linear model, a table must have a constant rate of change, meaning that when we calculate the change in y over the change in x, that's what this little triangle means, change in. So when we calculate how much y changes by and how much x changes by, it needs to be the same throughout the table. So here, if I look at how much y changes by, or f of x, they're the same thing, it goes up by 4. X goes up by 2, so for this part of the table, my rate of change, which is m, is 4 over 2, which is 2. Then for this next part, y goes up by 2, x goes up by 1, so my rate of change is change in y over change in x, which is 2. So far, this is a linear function because the rate of change is the same. But when I go to check here, from 9 to 21, y goes up by 12, x goes up by 3, so my rate of change is change in y over change in x. 12 over 3 is 4. So this one would not be linear because the rate of change is not constant. So let's check the next one. From negative 8 to negative 11, y decreased by negative 3, and x increased by 3. So my rate of change here was negative 3 over 3, which was negative 1. Then y decreased by negative 1, x increased by negative 1, so my rate of change again is negative 1. And then y decreased by 2, x increased by 3, so my rate of change here was negative 2 over 3, making it not linear, because again, the rate of change is not constant. So that's how to determine if something is linear or not. You basically check and see, does it have a constant rate of change? And if it doesn't, then it's not linear. So this next part, I want to actually write a linear model. So keep in mind that a linear model is always given by the equation y equals mx plus b. So in order to write a linear model, we need to know the rate of change and the initial value. So here at the bottom, just cross out 21 and write 15, just to make sure this is actually linear and has a constant rate of change. So step 1 to writing a linear model is to find the rate of change. So we did this one before, but change in y was 4, change in x is 2, so my rate of change is 4 over 2, which is 2. So now we need to know what the initial value is. There's a few ways we could find it. We could work backwards in our table. So we could say, okay, if my rate of change is 2, when x is 3, I have to go backwards 2. So y would be 1. When x is 2, I go backwards 2 again. Y is negative 1. When x is 1, y would be negative 3. And when x is 0, y would be negative 5. So I could find it just by using the table to do that. There's also an easier way of doing it. So the way we're going to do it is by taking our equation y equals mx plus b and plugging in the value of m into the equation and picking a point for x and y from our table. So let's pick 4 and 3. So I'm going to put 4 in for x and 3 in for y. So what that's going to give me is it's going to give me 3 equals 2 times 4 plus whatever my initial value is. So that gives me 3 equals 8 plus b. What does b need to be to make this equation true? If I subtract 8 from both sides, I get that b has to equal -5, which is what I found working backwards in the table as well. But this way is just a lot quicker. So my function is mx plus b, 2x minus 5. And to check that, I can just pick a value from the table. Let's say I pick 7, 9. If I plug in 7 for x, 2 times 7 minus 5 is 14 minus 5, which is 9. So it tells me that I did this correctly. So let's try the next one. My change in y is -3. My change in x is +3. So my rate of change is change in y over change in x, which is -1. So to find the initial value algebraically, I'm going to take y equals mx plus b, and I'm going to plug in -1 for m, and then I'm going to pick one point from my table, doesn't matter which, and plug it in for x and y. So I'm going to plug 10 in for y, -1 in for m, -2 in for x, and I'm going to find what b is. So 10 equals 2 plus b. So that tells me that b has to be 8. So my function is -x plus 8. And again, I can check it picking one of my points. So if I do y equals -3 plus 8, I do get 5. So that tells me my equation works out. And notice I've been kind of using y and f of x interchangeably. That's totally okay. F of x and y are kind of synonyms, so either one would be okay to use when writing our function rules.